This is a short video to provide you some quick tips on how to check your math results using nothing more than basic math and an in-your-head calculation or two. This material is designed so that you can quickly eyeball your answers from equations and make an educated guess on whether or not you've made an error calculating the result using your calculators. The technique used in this video will use only basic math rules as they apply to multiplication and division using exponents and scientific notation. So our first example is to multiply two scientific notation numbers together. 2 times 10 to the 9 times 2 times 10 to the 11. As it turns out, when multiplying by exponents, the exponents simply add together. So without even using our calculator, we can multiply the 2's together to get 4. And we know our number is going to be in scientific notation. So it's 4 times 10 to the 9 plus 11 is equal to 4 times 10 to the 20. So remember the rule in this exercise is exponents add together. In our next example, again we're going to be multiplying two scientific notation numbers together, but this time one has a positive exponent and the second one has a negative exponent. So we'll do the same basic thing. First we'll multiply the two prefix numbers together. 3 times 2 is equal to 6. Again, we know we'll be using scientific notation. So here, adding the exponents gives us a 9 plus a negative 11. When we add that together, we'll be left with 6 times 10 to the minus 2, which is the same as 0.06. In our next example, we'll be taking two scientific notation numbers, and this time we'll be dividing one by the other one. So again, dividing the two prefix numbers together. 4 divided by 2 leaves us 2. And this time, because we're dividing, we'll be subtracting the exponents. So our result is 2 times 10 to the 9 minus 11, which is minus 2, leaving us with a result of 0.02. So this time we'll be doing something similar, but instead of multiplying the numbers together, we'll be dividing with a negative exponent. So 2 divided by 2 is 1 times 10 to the 9 minus a minus 11, leaving us with 1 times 10 to the 20, because subtracting a negative number is the same as adding. In our next example, we're going to be taking two scientific notation numbers, with one of them taken to an exponent. So there is a shortcut to this one too, but we're going to draw it out first the long way. So this will be the same as 2 times 10 to the 9th times 2 times 10 to the 9th times 2 times 10 to the 11th. So we'll be using the same rules that we used before. Multiplying the 2 by 2 gives us 4 times 10 to the 9. And because we had the 2 as an exponent, we're going to multiply that together. Times 2 times 10 to the 11. So our number then becomes 4 times 10 to the 18 times 2 times 10 to the 11. Now taking the first two numbers and multiplying those together to the 18 plus 11, because I'm multiplying those together, leaves us with 8 times 10 to the 29. In our next example, we'll be taking a scientific notation number that's taken to the power of 2 and dividing it by 2 times 10 to the 11. So that's the equivalent of 4 times 10 to the 9 times 2 divided by 2 times 10 to the 11. The result is 4 times 10 to the 18 divided by 2 times 10 to the 11. Now we know since we're dividing here, we subtract exponents. So we're left with 2 times 10 to the 18 minus 11, which is equal to 2 times 10 to the 7th. In our next example, instead of dividing by a number to a positive exponent, we'll be doing the same with a number to a negative exponent. So we're left with 4 times 10 to the 18th divided by 2 times 10 to the minus 11, leaving us with 2 times 10 to the 18 minus a minus 11, resulting in 2 times 10 to the 29. All right, adding a little bit extra complexity here. Our numerator will evaluate to 4 times 10 to the 18 divided by 4 times 10 to the minus 22, resulting in the number 1 times 10 to the 18 minus a minus 22, with the result 1 times 10 to the 40. In our next example, we're going to add even more complexity. So we'll just be careful to do this one step at a time, reducing the chance that we'll make an error. So our first step is going to be evaluating the numerator, which is 6 times 6 divided by 3 times 3, all times 10 to the minus 11 plus 24 minus 2 times 8, leaving 36 divided by 9 times 10 to the minus 11 plus 24 minus 16. So our final result then will be 4 times 10 to the 3, or 0.004. Now that question was very complicated, and there were a lot of steps, so let's verify those steps with our calculator. So 6 times 10 to the 11 times 6 times 10 to the 24 divided by 9 times 10 to the 16 equals 0.004. So we verified the answer that we got doing it by hand without a calculator. Now let's try one final complicated example. So taking the prefixes of each number, we have 6 times 2 over 9 times 10. Now let's go ahead and add up all of the exponents. Minus 11 plus 30 minus 16. And that equates to about 1.3 times 10 to the 3, or in standard notation, 1300. Let's go ahead and verify this one as well. 6 times 10 to the minus 11 times 2 times 10 to the 30 divided by 9 times 10 to the 16. And we verify our answer that was about 1300. So just to summarize, what we've just done is we've taken what looks like some very complicated equations with scientific notation, with positive and negative exponents, and we've done them virtually in our heads. What I strongly recommend is that since we use some pretty nice round numbers in this exercise, just to give you an idea of how to use the methodology, when you complete your exercise using your calculators in probably much less nice round numbers, to just use this methodology to verify that the numbers that you get make sense given what you've been given in the problem. By doing this, you will potentially save yourself a lot of credit. Happy computing.